There are two ways to solve this absolute value inequality. The first way we're going to talk about is the intersection method. With the intersection method, we start by labeling one of the sides as y1 and the other side as y2. Using the function editor feature in your TI, you should obtain a screen that looks similar to this. Once you press Graph, you will obtain a screen that looks similar to this. Here, it is especially important to remember which side you called y1 and which side you called y2. It is also important to look at the graph and understand which graph goes with which side. Here, I've highlighted the colors to match the TI. So we have y2 is red and y1 is blue. Now, when I show my work on paper, I will draw a quick sketch of the graphs, starting with the axes. And then with y1 and y2. Notice it doesn't have to be perfect, but just enough to get the point across. I also suggest labeling each end of the functions with their appropriate names with the calculator. So now, once we have this on paper, we're interested in finding the intersection points of y1 and y2, hence the name intersection method. And what we really care about is the x values where these particular functions intersect. In order to calculate the intersection points, we will first press second, then trace, to call up the calculate function. Once you do this, your screen should look like this. Once you pull up this screen, the next thing you'll want to do is either scroll down and select number 5, or you could actually just press number 5 in your calculator and it will accomplish the same task. Now press Enter and you will obtain the next screen. Notice that the calculator is asking you the question, what is the first curve? If you see, the cursor is now located on the blue function, and that is y1, and we are fine with letting that be the first curve. Before we press Enter, it may be useful to move the cursor so that you're a little closer to the particular intersection that you want to calculate. So notice I have a choice of calculating the intersection point on the right side or the intersection point on the left side. If you just press Enter, the calculator will choose for you. Usually it's the closer one. So I'm going to move the cursor a little bit more to the left and then press Enter so that I can focus on this intersection point on the left. Once my cursor is closer to my desired intersection point, I'm going to press Enter, and I will obtain a screen like this. Notice the cursor automatically jumps to the second curve, and it's a lot closer to the intersection you wish to calculate. From here, we're going to press Enter one more time, and then we will obtain the next screen. The TI will then prompt to see if you want it to guess the intersection. Press enter one more time. And you will obtain the next item. This screen indicates that the intersection is at x equals -8. Notice that we don't really pay attention to the y value, mainly because the problem is asking for values of x such that the absolute value of x plus 1 minus 3 is less than or equal to 4. To find the other point of intersection, we will repeat the same process, only this time we will move the cursor closer to the other point of intersection on the right. To review the process, we press second, trace, and then for the menu, we press 5 to find the intersection. The screen will prompt you for the first curve. You'll move closer to the point of intersection. So normally the cursor's over here, but you'll probably move it a little bit closer over here. And once you get a little closer to the point of intersection, you'll press enter. And then it will usually jump to the second curve and ask you if this is the second curve. You'll press enter one more time. And then the calculator will prompt you if you want it to guess the intersection. And you will press enter one last time. This will obtain the screen that we have here. And you see that it has calculated the intersection point. And we find that the intersection is x equals 6. And again, we ignore the y value because the problem is asking for all x values such that the y values are less than or equal to 4. To actually find the solution of the inequality, usually we will draw a quick sketch of our calculator graph onto our paper. And when I do sketch the graph onto my paper, I will usually label both sides of each graph with its appropriate y1 or y2. This will help me determine the solution to the inequality. Now, in order to determine the solution, remember that we just calculated the intersection points. We found that x was -8 and x was also 6. And these will be very important for the endpoints and starting points of your solution. So in order to understand this a little bit better, I'm going to rewrite this inequality or make you think about it in words. And what I'm trying to get at is we are asking for what values of x give us y1 such that it is less than or equal to y2. In other words, we could ask ourselves, when is y1 below y2? So what values of x is y1 below y2? So I'm going to start off by reading my graph from left to right and just try to determine. Notice that these boundary points break up the inequality or the graph into 3 sections. the interval from negative infinity to negative 8, the interval from negative 8 to positive 6, and the interval from positive 6 to infinity. So we want to find which of these intervals give us a y1 below y2. And notice that because we are labeling our graphs on each side, we have some nice color coding going on here as well. We can actually determine this a little bit nicer. So if I'm going to look at the interval from negative infinity to negative 8, notice that all my y1 values are above my y2 values for all these x values in this interval. And that is not what the inequality is asking for. So I know that is not the solution region. I'm then going to move over to the interval from negative 8 to positive 6 and look at all these x values in between here give me a y2 bigger than a y1. Or if we want to read it a little bit differently, all these x values give us y1 smaller than y2. So the x values in between negative 8 and positive 6 will give us y values such that y1 is below y2. And I think this is our solution, but we just want to check the last region just in case. So all the x values from 6 to infinity, notice that they give us y1 values greater than y2 values. So these are not our solutions. So I've just written the solution in a one-dimensional case on this number line. You may want to decide what your endpoints of the solution will be. And how we do that is look at our original inequality symbol. And notice that less than or equal to will indicate that we use brackets on the end of each endpoint. So now I have a one-dimensional solution of my inequality. I'm going to rewrite the final solution in interval notation. And that will be all the values from negative 8 to positive 6. And we've just solved an inequality graphically, and I think you'll see that when you compare it to the analytical solution, they'll match up. Yay!